Question 17 from 9.6 asks you for the name of the shape, the most specific name, and it looks a whole lot like a trapezoid. It kind of looks like an isosceles trapezoid. So let's just verify here. Notice that we're at a y-coordinate of 4 here. We're at a y-coordinate of 4 here. So the slope of that's a perfect horizontal, right? Because the y value doesn't change. Down here, this is along the x-axis, that's along the x-axis. So those are both horizontal. Those lines are going to be parallel. Pretty obvious that these aren't parallel. If you really want to check the slopes, you can check that, but it should be a trapezoid. I believe it's isosceles. We'll take another look at that in just a second. So we need to find the area. If you think back to, I don't know, 6th or 7th grade, whenever you learned the trapezoid area formula, you certainly could use that, half the height times the sum of the bases. The book does not expect that you've seen it, although you probably have because you took middle school. So what they expect you to do is to break this up into right triangles, and that's going to be a running theme for quite a while for us, is breaking shapes into right triangles. So drop a perpendicular right there, drop a perpendicular right there. Again, because everything is horizontal and vertical here as far as the dimensions of the sides of the triangle, we should just be able to count units here. So this entire base is going from -4 over to 11. So that entire base is going to have a length of 15, okay? Notice we're 8 units over here. Remember, horizontal movement is x. We're 8 units over here. We end up 11 units over here. So if that's the point 8, 0, right? You're over 8, up 0. We're moving from 8 over to 11. So that side's going to be 3, okay? Back here, we're back -1 in the x direction. And of course, the y-coordinate's going to be 0. So notice we're going from -1 over to -4. That length is also going to be 3, okay? So we've got a whole length of 15 here. We've got a length of 3 there and a length of 3 there. If we subtract 6 from 15, that leaves us with 9. Notice there's a rectangle right here. So we've got a rectangle with a base of 9, we've got a triangle with a base of 3, and another triangle with a base of 3. We need the height, okay? Look at your y-coordinates. We're going from a y-coordinate of 0 to a y-coordinate of 4. So that height there is 4, y-coordinate of 0 here to a y-coordinate of 4 there. That height is also going to be 4. So we've got a 9 by 4 rectangle. 4 times 9 is 36. We've got a base and a height of a triangle here. So we know again from 5th or 6th grade, half the base times the height is the area of a triangle. So you can take half of 4 times 3. That area is going to be 6, and that area is going to be 6. So the area is going to be 36 plus 6 plus 6. You can add that up. The length of PR, notice you've got a little 3, 4, 5 right triangle. You've got another little 3, 4, 5 right triangle there. So look for right triangles. Altitudes and shapes are usually going to make right triangles. Really, really, really important for things moving forward. All right, 18. We've got this sub that's moving north a kilometer and then west, and then north, and then west, and then north, and then west, and so on. I originally thought, oh, look at all these little right triangles here. I can just find the hypotenuse. 1 squared plus 1 squared is 2. If you take the square root, that would be radical 2. And so I thought, oh, we're just going to have a bunch of radical 2's along here, and I just have to figure out how many radical 2's there are. And then I realized something. If you're going to go 41 kilometers, you're going to do 1 more north than you go west. And so the problem is, you're going to start going north, and you're going to end going north, okay? And this obviously is just a small piece of that. But what's going to happen at the top is you'll have an extra north at the end, and yeah, you'll have radical 2, radical 2, radical 2, radical 2 all the way up. But then that's not going to end at that point. You're going to be off slightly. And so then I said, well, oh gosh, well, this is really weird, because if you imagine, imagine that I'd gone up and over 41 times. If I start going up and I end going up, my length between those is going to end up like kind of cutting between these. How am I going to find dimensions of those triangles? That's ridiculous. And then I thought about the problem a little bit differently. If you're on a block system in a city, for example, if you go up a block, over a block, up a block, over a block, up a block, over a block, that's the same thing as going up this many blocks and over that many blocks. And notice your total distance from your starting point to your ending point would be the diagonal of that triangle. So I thought, well, why don't I just figure out how much I go up total and how much I go over total? If you remember, we're going to go up 1 more time than we're going to go over, and it's a total of 41 kilometers. Okay, so if you break that up into 21 north and 20 west movements, so you're going to go up 21 kilometers, and you're going to go over 20 kilometers. And you might remember a triple, I don't think I talked about this triple in this class. Anyway, this is probably a Pythagorean theorem problem for most of you. So 20 squared plus 21 squared is equal to c squared. And you can solve that. I believe it's going to end up being 29 kilometers from the start to the finish. So interesting strategy, great problem-solving problem, which of course is why you decided to take an honors class in the first place, to see some of these problems that are a little bit outside of the box. But not a very long problem, just something you have to kind of draw pictures and think about a little bit. So I hope that helped.